This is Algebra 2 at Trig, 2A.1b. We're talking about end behavior. This is a topic that we've talked about before, but now we're going to do it just looking at equations rather than looking at the graph, specifically a quadratic as we did it before. Now we're going to have several different degrees and leading coefficients. The end behavior of a function's graph is the direction the function goes as x approaches plus and minus infinity. As we move to the left, where does the function go? And as we move to the right, where does the function go? That is your end behavior. We're not worried about really what's happening in the middle, but so much what happens on the far ends. So what we're going to look at here is our odd degree. What do you know about an odd degree? We're specifically going to look at a positive leading coefficient. So an example of that can be just a straight line. That has an odd degree. X to the first power would be odd degree. If it's increasing to the right, it has a positive leading coefficient. So what we notice is it goes up to the right, and to the left it goes down. As x approaches positive infinity, as x gets bigger, we notice the y value is going up. It's going to positive infinity. The further to the left we go, as we approach negative infinity for x's, the graph continues to go down. So that's approaching negative infinity. Now this is going to be true for any odd degree. So if I put x into our calculator, you'll see to the right it goes up and to the left it goes down. That's an odd degree. Another odd degree would be to the third power. Third power is an odd degree. And you see that when it goes to the right, it moves up, and as we look to the left, it goes down. Even if there's a lot of things happening in between, if you use more parentheses, like x plus 4, x plus 2, and x. Let's just pick those three x's, third degree. We have our linear, and then we go up, down, and up. There's going to be a lot of movement in the middle maybe, but eventually it's going to increase to the right and it's going to fall to the left. Every odd degree. On this side, we're looking for another odd degree. So we're recognizing the pattern that odd degree is going to open up in opposite directions every single solitary time. But now we're going to look at what happens when we have a negative leading coefficient. A negative leading coefficient is going to fall to the right. Every time you have a negative leading coefficient, you're going to fall to the right. Every time you have an odd degree, you're going to be going in opposite directions. Leading coefficient tells you which direction to the right you go. Positive, you went up. Negative, you go down. The odd degree tells you you go in an opposite direction. So maybe this graph could possibly have gone up. This would probably be called a third degree, maybe, because it's crossing up to 3 times. But we're not concerned about that. We just want to know odds, positive or negative. So as we look to the right, an odd that's negative is going to go down. And as we look to the left, the graph is going to go up. So what do you expect is going to happen when we're working with an even degree? With an even degree and a positive leading coefficient, it's positive, so you know that it goes in the positive direction to the right. Even tells us that it's going to go in the same direction. Just like quadratics you've done before. X squared, that's an even. They're both going to point up. What if we had x plus 3, x minus, no, say x plus 1, x minus 1, and x minus 2. It might fall off the screen there a little bit, just a tad. So if I go down a little bit more, in my window, I can look to see where my minimum is, and I can make it go down farther, and then we can see it through the curves. Fourth degree is going to cross up to 4 times. That's a different lesson, really, but so if it's positive, it goes to the right up. Even, it goes in the same direction up. If you have an even degree and you're a negative leading coefficient, negative tells you you're going to be going down to the right. Even tells you're going to be going in the same direction as you move to the left. What happens in the middle doesn't matter. We know that as x gets bigger, the graph is going to fall to the right, so it goes to negative infinity. As x gets smaller, the graph goes to negative infinity. What happens here in the middle is somewhat irrelevant. That's not what we're talking about right now. We're just mainly talking about end behavior. Now, can we do that by looking at the equations themselves? The main things we're looking for are the degree and the leading coefficient. So what is the degree that you're looking at here? I see a 4. Now, I don't care about the 4. It could be a 2, it could be a 6, it could be an 8. It doesn't matter what the degree is, as long as it's an even number. That's the only thing that matters. I notice that the 4 is an even number. So I'm going to focus on the even part. I notice that the leading coefficient is a negative. The largest exponent has a negative. So that's your leading coefficient. So we can look for that pattern up here, or we can just consider what it would be. Negative means it falls to the right. Even means it goes in the same direction. It's really all we need to know. So as x approaches negative infinity, the function falls to the left. as x approaches positive infinity, the function falls over time. What do we think about that? That doable? You can either use the chart, but then you're relying on something to always have to look back at. You can start to use the idea that negative means fall to the right. Even means it has to go in the same direction. Use your past knowledge. Even is like a quadratic. You know what x squared looks like. So x to the fourth, that could be new for you. X to the fourth is doing the same looking like thing. Looks just like a parabola. If you zoom way close in, x to the fourth looks a lot like a parabola. It never goes horizontal. It looks like it's going horizontal. It never goes horizontal. It just gets closer and closer and closer and closer. And then it touches the x-axis right at 0. And then slowly but surely it gets larger and larger. And then it goes up quick. Okay? This degree is odd because it's a 3. That's the largest leading coefficient. Be sure it's in standard form first. You got to be observant to that. All of these are in standard form. But you would need to be observant to that. So 3 is your largest exponent, so it's odd. Your leading coefficient of that term, in this case, is positive. So positive tells me it's going to increase to the right. Odd tells me it's going to go in the opposite direction. It's the only thing that matters. As x approaches negative infinity, this g of x is going to go down. And as x approaches positive infinity, g of x, as x gets bigger, g of x goes up. What happens in the middle doesn't matter. We're just talking about end behavior. What pattern do you see about degree 2 and degree 4? This is a degree 4. Degree 2 and 4 both head in the same direction. We don't know if it's heading up or heading down, except if it's positive or negative. But the degree of 2 or 4 tells us that it's going to be going in the same direction. Odds will go in opposite directions. Here's another demonstration of that. The first degree is an odd degree. It goes in opposite directions. 2 is an even degree. It goes in both directions. Well, they both go in the same direction. Odd degree, 3 is going to go in opposite directions. Even degree, 4 is going to go in the same direction. Every time. Odd degree, 5 is going to go in opposite directions. It can cross up to 5 times for the 5th degree. It doesn't have to cross 5 times, but it could cross up to 5 times. 4 degree could cross up to 4 times. 3rd degree could cross up to 3 times. 1st degree can cross up to 1 time. It would have to cross one time. Second degree could cross up to 2 times. You know it can cross once, and you know it can cross 0 times. Okay, you go ahead and determine what your degree is for each of these. Are they even? Are they odd? The number doesn't matter. Not looking for the number. And what's the leading coefficient? You can pause the video, work through these, and we'll come back and do them. So here, what you want to look at first is that the graph is heading up. When it's heading up, you know it has to be a positive leading coefficient. This one's heading in opposite directions. So you know the degree is going to be odd. This is probably an x cubed graph. This one to the right is going down. So you know that it's negative. The degree, because they both go down, you know the degree has to be even. Just like a parabola. They go in the same direction, and a parabola is even. This probably isn't a parabola, or isn't a parabola. It's probably a 4th degree. This one looks like a 3rd degree, but I doubt it is because of this little, it's not very consistently smooth through here. So I bet this is more like a 5th degree, but that doesn't matter. We're not looking at that. We're looking at, is it even or odd? Is it positive or negative? Because it falls to the right, it's negative. Because it goes in opposite directions, you know that it's odd.